Good afternoon, everyone. My name is Sohini Ramachandran. I'm the Herman C. Bumpus Professor of Biology, and I serve as Director of Brown University's Data Science Institute. I'd like to excitedly welcome you to the first in a year-long series of conversations on campus, convened as a partnership between the Provost's Office and the Data Science Institute on AI and our data-driven society. Our goal in this series is to discuss the implications and uses of AI in research, teaching, training, and policy, and the implications it has for our campus community. The importance of exploring these implications was underlined by the new executive order on AI announced yesterday at the White House, where both President Biden and Vice President Harris called for more research into the broader societal impacts of AI. And we'll hear a little bit more about the background on this from one of our panelists today. Through panels featuring the expertise of faculty and staff from across many disciplines across the university, we hope to engage the broader community in cross-disciplinary discourse about our data-driven world and stimulate new research connections, pedagogy, and disciplinary and cross-disciplinary interaction. This first event is called Let's Chat about ChatGPT. So this title was, of course, stimulated by the launch of ChatGPT just 11 months ago, which is sort of hard to believe it was just that little time ago. But this conversation is also going to highlight that this is the latest iteration in the long evolution of AI and conversations about AI over the last 40 years. Today, we'll touch on that history and why it is that AI is suddenly in the public eye. We also hope that you will join us at our next panel on November 30th, entitled Whose Work Is This? Authorship in the Age of Generative AI. And now I'll briefly introduce our wonderful moderator of today's panel, Frank Doyle, who is a professor of engineering and the 14th provost of Brown University. As the university's chief academic officer and chief budget officer, he works closely with the president to advance the university's mission of research, teaching, and service. His own research in AI has ranged from work on dynamic neural networks in the 1990s to the application of AI in the design of a smart artificial pancreas to deliver insulin to individuals with type 1 diabetes in the last 5 years. As Dean of Engineering and Applied Sciences at Harvard, Frank helped launch the $500 million Kepner Institute for Natural and Artificial Intelligence in 2022. He is also often invited to speak at international venues on the role of AI in the academy. So I'll hand the proceedings over to Frank now.
All right. Sohini, thank you for that kind introduction. It's great to be here, and I'm really humbled to be on the stage with these distinguished panelists. It's going to be really fun to have the conversation with you today. I thought what I'd do is just give a quick snippet of background for each of our three panelists here, and then let you amplify further anything I missed in your background. And then I'm going to call on each of you as we go through the introductions to tell us what you're teaching this semester or next semester, but for the students in the room who might be interested in this topic. So let me start with Ellie, to my immediate left here, Ellie Pavlik, who's the Manning Assistant Professor of Computer Science and Assistant Professor of Linguistics here in Brown. Her research is in natural language processing, and she's the founder of the Language Understanding and Representation Lab at Brown. She's led scientific analysis and evaluation of Bloom, the open access and responsibly developed 176 billion parameter multilingual language model. Her research ranges from grounded language learning to representation learning to computational social science. So tell me what I missed and tell me what you're teaching this year.
Yeah, no, I think that covers most of what I'm doing. So I also work at Google as a research scientist. I have since my postdoc, and I've maintained an affiliation. So I've had a lot of it's been a very interesting past, I would say, 5 years or so, watching the rise of these large language models from the academic side, the industry side, the open source side. And yeah, I'm teaching natural language processing. I actually just came from class, so I was worried I was going to be late, but we cut the lecture a little bit short. But yeah, so that we've mostly been talking about exactly these issues, the technology under these kinds of models and their predecessors.
Fantastic, great. So to Ellie's left is Suresh Venkatesubramanian. Suresh is professor of data science and computer science, trained in theoretical computer science, and spent the last 11 years really studying the societal impact of ML, machine learning. He has an interdisciplinary perspective on the field and deep expertise in AI policy. In fact, he helped write the blueprint for the AI Bill of Rights in his time in Washington recently, which is now enshrined in the recent executive order on AI, which you probably have all been reading about in the paper this week. Suresh, what else would you like to say about your background, and what are you teaching this year?
Well, I would say for the students in the room who always ask, how do I, how did you know you want to work on this? My answer is I just wandered into it from many different areas. I've explored many parts of computer science, and I'm here now, and I don't know if I'm going to leave, but it's a nice area to be in. What am I teaching? I'm teaching in the spring. I teach a class called Fairness and Automated Decision Making. It's a class that says we've all heard about the issues associated with using machine learning in society. We've heard about the problems. What do we do about it? And so the class really focuses on what tools we have at our disposal to make better systems, less biased, more transparent, more accountable. And they're not perfect. Students get frustrated in my class because I'll give them these tools, say, well, this is how this tool's broken. But it's an invitation for them to do better and build better tools. And that's where we are.
Fantastic, thank you. And last but not least, on the far end of the stage here, Stephen Bach, who's an assistant professor of computer science here at Brown. And he does research on machine learning, particularly how to more easily teach and instruct AI in new tasks and concepts. He co-led one of the teams that simultaneously proposed instruction tuning, the process of explicitly training large language models to follow a wide range of instructions, which is now a standard part of language model development. He works on interdisciplinary collaborations, developing AI for data science applications. Stephen, what did I leave out, and what are you teaching this year?
Sure. Well, at first, I'd like to mention all of the great collaborators that are part of those interdisciplinary collaborations. Some of them are Nicole Nugent in the medical school, Jonathan Pober in the physics department. We've been developing different AI applications for everything from helping researchers conduct studies that give us insights into adolescent mental health to astrophysics and making sense of radio astronomy data. So I think that's something that is an important part of our work that I'm really excited about. I'm also a researcher at Snorkel AI, which is a company that does machine learning for enterprise applications. And this year I'll be teaching a course just called Machine Learning in the computer science department. Folks who take that will see the whole breadth of machine learning techniques, not just the latest deep neural networks that are very popular right now, and hopefully come away with the tools to see how all of the exciting things that are happening in the news kind of fit under that framework that's been around for a long time.
Terrific, great. I should say, I'm going to drive the first half of the conversation here with some questions, and then we'll have a way for the audience to volunteer questions in the second half, and Sohini will help us collect those questions. So let's start with the basics. There's the proverbial alphabet soup of acronyms here that are floating, not only in the conversation we've already started, but around the field. AI, ML for beginners, but LLMs, GPTs, GOFAI, which was a new one for me, I have to say. So maybe Ellie and Steve, do you want to start? Help us translate a few of these acronyms for the audience here.
Sure, I'm happy to start. I think it's funny, all the acronyms, like it's very clear that like marketing was not involved sufficiently early, right? GPT stands for Generative Pre-trained Transformer, which is not, like that's a terrible name. It's a terrible name. So yeah, so one can be forgiven for not being able to keep track of all this. But I think one of the, the big differences, or the big one that you said is kind of the AI versus ML, so artificial intelligence versus machine learning. And that is something that I think researchers still kind of are, like they're actively quibbling about where the current technology falls in this. So artificial intelligence is very much like a very old ambition that dates back, you can argue as far back as like Plato and Socrates, but definitely at least the 50s was like a kind of a heyday of we have computers, and is it going to be possible to like replicate human level intelligence in a non-human thing, namely in a computer? And so that kind of work involved a lot of theoretical computer science, things like search and planning algorithms, robotics and language and vision and a lot of logic. And so a lot of kind of traditional computer science techniques that have nothing to do with what we call machine learning were part of AI and are still kind of thought of part of AI. It also is the case that artificial intelligence has traditionally interfaced a lot with the study of human intelligence, so with cognitive scientists, philosophers, neuroscientists, a lot of the humanities. The machine learning kind of came about, I would say, more recently with improved statistical modeling, so much more just grown out of statistics, and you can think of it as predictive modeling forecasting the stock market, forecasting weather patterns, those kinds of things. And as those tools got better and better and better, more and more of the things we tried to do in AI got subsumed by statistical modeling, to the extent that the models we currently have right now are arguably, they're just machine learning models. They're statistical predictive models of not such a different flavor from that other kind of stuff. And so when people have been talking, there's like a bit of a rebrand of people wanting to call it AI because it looks so good, it looks so powerful, it seems like it's doing human level reasoning. And then so there's kind of a bit of debate, I would say, about whether it's fair to call it AI or whether it's just very good machine learning. But I think that kind of history and that context is pretty relevant. And when you talk to people who are in the field and working on the technology, it's not always, there's not always agreement about when to call it AI versus just machine learning. Steve, I don't know if you have things to add specifically.
Oh, yeah, no, that was great. I'm one of the people in our group, we are unashamed to say that what we're doing is probably just pretty good machine learning, or maybe even we'll just say machine learning, not necessarily intelligence, and that's not necessarily one of our goals. But you'll notice even in the intro, like we've adopted the AI moniker that people do, that just kind of connects with people. I think the thing about machine learning that I want people to know is one of the things that we cover in the first day of class in computer science is that machine learning, unlike what Ellie was describing about the lofty goals of AI, you can view machine learning as just another way to program computers. And the first way to program computers is what you probably imagine when you think of a computer programmer, somebody sitting and thinking about writing precise instructions and deciding exactly what the computer should do. Machine learning instead says, give me a bunch of data. Give me data that says what the inputs to my program are going to be, and give me the outputs that the computer should give in response. And then it's just a search over many different possible programs until you find one that tends to do pretty well on that data that you've collected. And a lot of that is statistical based. Again, as Ellie said, like that was one of the big advances in machine learning, that once we were able to incorporate uncertainty into this search over programs, they became much more powerful. And I think a lot of why we're here today is because some of the machine learning applications have really made inroads on things like language modeling and other AI goals that are older and distinct from machine learning.
LLMs? Everyone want to take a
Yeah.
stab at LLMs?
Yeah, so this, I think this kind of historical context we've talked about, like what's new and what's not. So neural networks, that's kind of the current thing that's getting everyone's attention. That's also not super new. So that was a form of, actually I'd say it fits into AI more. So the neural networks is a technology that came out around the 1980s, trying to model the human brain, right? Like that's what neural came from. It's a very, very simplistic model. If you talk to a neuroscientist and who knows anything about neuroscience and they look at the kinds of models that were out in the 80s, or they're like, that's not at all how the brain works. But at a very, very high level, it was a simplified version of how the brain worked. And so it was meant to try to model intelligence, doing exactly what Steve was describing, saying, here's a lot of data, here's what the inputs are, here's what the outputs should be. Can you figure out the best way to get the outputs for the inputs? And it was deliberately a contrast to something that looks more like a traditional computer program that said that the brain or the mind is really structured as something that looks like a set of rules that you might apply to your inputs to get your outputs. So that technology was there in the 1980s, and it's been around, and a lot of these debates and things that we're having now had then, like if you read stuff written in the 1980s, it could have been written today about the kind of technology they had, about like, is this human level intelligence, things like that. But then they kind of died out because they were just failing to really give impressive performance, especially on things like language. Like language was just thought to be too complicated for these very simple models. And so people kind of gave up on that and started working on other types of machine learning models, other types of AI models. And then what has happened recently is people just said, let's go back to that old technology. Let's just make it way bigger. Like we have a lot more computers now. They're a lot faster. We have a lot more data. Like the internet happened in that time period. So there's a lot of data now that we can use to train these models. And we've come up with better hardware that can train them very quickly. And there's, of course, a few other small technological innovations, but not like anything really deep. And somehow that difference, just training much larger ones on much more data, has been the difference between people stop paying attention to it to the kinds of models we have now, like ChatGPT. And so LLMs is the large language models, and it's just very, very big neural networks that are trained to do language. And specifically what they're just trained to do is generate sentences like one word at a time. And so it is a bit of a surprise, I would say, how good they are, because it's not like somebody had a brilliant insight that said, I think this is the missing link, and once we add this in, the computer will be able to do language. It was more of a stumbled upon thing of like, let's try it. What if it gets, as they get bigger, they seem a little bit better. Let's keep going. And then we've fallen into these kinds of models.
That's great. So if I think back to the 1980s when I was a student, and these sum and squash type models, as they were called, were in the technical landscape. There were a number of folks looking at them. It was not in the public arena, right? People weren't reading about AI in the paper at that time. They weren't reading about neural networks. But today, it's safe to say probably everybody in this room has heard of ChatGPT, and the title of the session at least, so you read about it coming here. What has changed so that everything is in the public space now? What is it about the connection to society, the consequence? And maybe Suresh, you want to start with this one?
So today I met the first person I've ever met in my life who did not know what ChatGPT was.
Oh my God.
He was, he was in the government.
Probably writing the policy, is it?
No. But for good reason. This is not a dig at anyone. I mean, but I was surprised to find someone who had not heard of ChatGPT.
Yep.
They're thankfully busy doing more important things. So I have a number of theories about this. Part of it is a growing awareness of the importance of technology in our lives that goes back to things like Cambridge Analytica and Facebook. It's a weird connection to make, but it was with so for those of you who don't know, there was this scandal involving data that Facebook was collecting because people use Facebook, selling it to a company, which then repurposed it for doing targeted voting and targeted, pamphleteering and basically political ads. And then the whole argument about to what extent the 2016 elections were affected by this, and other countries as well. It was the first point where people realized that tech was having a non-trivial impact on our lives in ways we couldn't control. So that kind of raised the temperature a little bit, but still not a lot. Then over the years, more revelations about social media came out. Again, raised the temperature some more. And then ChatGPT's release, and everyone can go on the website and play with it. And suddenly, I think to Ellie's point, the things that researchers knew for a long time were getting slowly better, suddenly appeared. It's almost like, literally the iceberg, the top just popped up. And then everyone saw the top of the iceberg, like, whoa, this thing just appeared. But it was there, we just hadn't seen it. And I think it became, putting my sort of more political policy hat on, right? It became what they call a kitchen table issue in a way that AI and technology had not been. I mean, I've been working in the trenches around AI bias and discrimination for a long time. People in policy were paying attention, but the public didn't care. No one was really paying attention to this. It was a very obscure issue. Someone goes to jail because they shouldn't. Well, it doesn't affect me personally. What do I care about it? That kind of thing. But this affected everyone because everyone could play with it. Everyone could see the potential. Everyone could see the excitement. Everyone could see the weirdness about it. And that's my take on why it's become a household name now.
Yeah. It's introduced some interesting terms of art, like hallucinate, into
yeah, I don't like that word.
understanding of things the tool might do. So let's stay on this theme of sort of the public attention. And Suresh, if you don't mind, I'll keep focusing on you. The news this week has talked about the exciting executive order from the Biden administration. There's conversations happening in London, as we were talking about before the session. A lot of attention on the questions of policy. Yeah. And, one might offer the proposition that the left and right of this argument, if you will, have both said, what's been articulated in this executive order, it's not enough, it's too much. So is it the right thing by virtue of the fact that it's down the middle of the road, or is there more we can be doing? What's your sort of take on things, knowing that you've had an insider's ride on this?
Yeah, I mean, I would say that there is no silver bullet to addressing the issues associated with the use of automation and AI that affects us all. There are a number of different things. There is a lot of, voluntary efforts by companies to sort of build better responsible practices into how they use their systems. There is legislation that Congress will hopefully put forward. I was at a I was at a hearing last week with Senator Schumer, and they're trying to figure out a way to sort of build legislation around this, and we'll see what happens with that. There's the regulatory agencies, the Federal Trade Commission, the Equal Employment Opportunity Commission, others have been paying attention to whether these systems are discriminating in some way and we should do something. And the White House, the executive order is basically the most powerful thing the president can do on his own. And so he did it, basically. So I would say all of these things are good. They're all steps forward, and they're important steps forward. We're going to have to wait and see, how they play out. But again, as you mentioned, things are happening on the international stage as well. So there's a lot of activity. A lot of that is noise. A lot of that is people feeling that they have to do something because people are expecting them to do something. So some of it is just like, yes, okay, fine, you can do your little thing. Some of it is real. I think this executive order is real because it's going to have non-trivial effect on how agencies do their work, which means that if you are applying for benefits, or if the drug is being approved based on AI, that's going to affect you directly, and that's something that now they have to take care. The federal government has to pay attention to in how they regulate and do these things. So yeah, I think it's an important step forward. And you talked about the left and right. I just want to say, this is one of those very rare, weird issues that does not cleave along the normal left and right lines.
No, I meant metaphorically left
yes,
and right,
yes,
not
yes. Sorry.
politically.
Yeah.
Right.
And it's because of that, there's actually a hope of something coming out of Congress, because the Congress has been doing this in a very bipartisan way, which I think is healthy. And there are issues that people may be concerned about them for different reasons, but everyone agrees that something needs to be done. So I think in some sense that's a good.
So, I had a dear friend, I would dare call him a mentor, Ash Carter, in my former profession, who used to speak about the virtuous cycle of technology and policy, that you can use technology to inform policy, you can use policy to regulate technology. How does that cycle play, and anybody could jump on this question, with things like, let's say, Commerce is talking about doing watermarking for AI-generated technology. What do you think the feasibility or difficulty of bringing technology to help us with policy questions like this?
I'll go first, but I think both of you will, I'm sure, have things to say. I will say that to the extent that people think, and there are still many in government who think, that the solution to problems with technology is more technology, it will fail. I don't think Commerce thinks that watermarking is a solution to deepfakes, but there are people who do, and they are wrong. The solution to problems with technology are to recognize that the problems with technology are the problems with technology and society, and that we need a broad socio-technical approach to thinking about this, which means we need to understand how people interact with technology, which means we need to understand people, which means we need all of the disciplines that help us understand how people work together in society. As long as we're doing that, then these approaches will be part of the solution. But if we think that technology on its own will help solve these issues, then they won't.
Fair enough.
Yeah,
Ellie
no,
or
I,
Steve? Yeah.
yeah, I think that's great, because I was going to say a similar thing. Like, I think one thing that I've actually been excited about the idea of technology policy is that typically when people are thinking about regulation, it's like there's this awesome innovation happening, and then regulation is going to come in and slow it down, right? Like that's kind of like the typical story is like we're gonna do this stuff, and the government's going to come tell us we can't. But actually, I think what's the kinds of things that are being talked about as the kinds of demands are would actually spur research and innovation, because the technology we have doesn't know how to address those problems, but really needs to. And sometimes the type of innovation that we see happening right now is exactly what Suresh is talking about. It's like, let's just put more models on it. From what I've seen happening in industry, the most common way of avoiding these problems is to train another chat GPT to teach the first one what not to do. This is literally the problem. Yeah. And so that, I think everyone knows why that feels wrong, right? So regulation that comes in and says, hey, you need to be more creative than that. Like right now, we know you're good at building chat GPTs. You can't just apply this one hammer to everything. We're going to require something more. I think will actually lead to a lot more diversity of the kinds of research we see going on, the kind of technology that's being built. So it feels like actually a pretty exciting opportunity to get more innovation. It's not like, I don't think it will slow it. I think we'll get better stuff out of it.
Yeah, I just want to add one thing I admire about Suresh's work, who's been at the forefront of a lot of this, is exactly what you said about the socio aspect of socio-technical problems. And one thing that I've observed a lot that I think might be an issue that I think should be more of the conversation about regulation is the amount of trust that we put in AI. So this iceberg has kind of emerged, as you said, and in some ways, in some dimensions, it's as big a deal as people are imagining, but in other ways, I think it's been kind of overestimated. And you see that in the types of decisions that already people are trying to delegate to AI. And so it's, to me, not just a question of, what should an AI be capable of, but when should we turn to it? And that's something that a lot of people are already speaking about and drawing attention to, but I want to emphasize that because, and I do attribute it, I like that metaphor of the iceberg kind of bursting up, that people are kind of so surprised by this in some ways that sometimes they're not examined, the capabilities of these models are not examined as critically as they should be. And that something that seems to be plausibly doing a good job at a task, like making high stakes decisions, like you already mentioned, there's a willingness to turn over important societal decisions and to an AI that there's no basis for that trust, and I think that's another job that we have to do as AI people is to try to make that more clear.
Great, thank you, Steve.
Can I say one thing?
Yeah, please.
It's kind of funny. I used to be in many rooms where I was the only computer scientist in the room. There's a bunch of lawyers and me. And I'd be saying things like what we're all saying. They're like, "You're the computer scientist. Why aren't you more positive about the technology?" Because I've actually had to use it and I've had to build it. When you have a student working 3 nights to train a network that is not producing reproducible results, and then someone comes and tells you that AI is sentient, it's like, I mean, you both know
Right.
this,
Right, we know just how bad it is.
Yeah, because
many
people
times.
don't advertise that part, right? The press release is not showing all of the things that didn't work, and the papers aren't showing all the things that didn't work. And we also said this is there were models before this. OpenAI released theirs, and suddenly the public was paying attention. But everyone who saw everything, you're like, I didn't trust any of those off by one versions of this model. Why should I trust this one random point in the middle? No.
Well, that's why I have to say I get frustrated when people draw analogies as we think about policy, teaching policy and using the tool. People will say, well, the calculator didn't change how we necessarily taught mathematics and so forth. And the distinction I often make is the calculator is precise. It gives you exactly the answer that you are asking for. These tools you have to use with caution. So we've been out kind of thinking about the national landscape, policy, regulatory, even international consequences. Let's zoom in for a minute to Brown, and in many ways a preview of the series, as Sohini said, that we're going to be having over the coming academic year. But there are incredible, really a vast array of exciting things happening across the Brown campus here. And I wonder if we could just sort of sample a little. And I'll start, Steve, with the term you had used earlier, the socio-technical computing research. I'd invite any of you to speak to that thrust, that strength that we have, which one might argue is uniquely Brown, right?
Yeah, I think maybe Suresh, you should start with that and your work in the center.
Okay, I'll hand it over to you. So, what is socio-technical computing? Maybe first of all, right? So it's a growing idea and a vision that if we are thinking about systems of people and technology intermeshed, then we have to understand that interplay in a way that isn't coming only from one direction. It's only not, and often not just from the technological side. And how that works depends on the problem, but we have to bring together people in different spaces to think about a problem from their own perspective. So one of the things I'm doing now, which I forgot to mention when you asked us to mention our bio, is that I direct a new center for tech responsibility, reimagination, redesign within the Data Science Institute. That's one of the 2 centers within the institute. And the founding vision of the center is that if we want to reimagine how we do responsible tech design, then we have to reimagine that with all the people involved who can bring their expertise to bear on the problem. So if I'm, for example, trying to write a paper about how algorithms might be viewed in the court system, I am working with a lawyer to do that. We're actually working together. If I'm working on a paper on, I'm just thinking off the top of my head, on how we what are the kinds of mistakes we make when we interact with technology, and what can we learn from the history of science and technology? Then I'm working with sociologists and especially historians of science who think about that. And so that perspective is, you have to bring that perspective in, and which is, I think, a very Brunonian thing to do if you want to truly engage with the problems you're dealing with because of that. So socio-technical computing is a vision that says, yes, there is computing, there's also people and society and humanity in how we think about these questions. And that's going to actually give us both better tools and better ways of thinking about where they're useful and not useful. That's the vision.
Yeah, I love that vision. I would just add that in our group at Brown, we're mostly focused on a particular set of technical problems that I think falls under this vision, where we have people who are not necessarily computer scientists who have concepts, tasks that they want the model to understand, I'll put understand in finger quotes, but understand well enough to carry it out to a useful degree. And so we mentioned at the top some of the collaborations already happening with the medical school, with researchers in the medical school, researchers in the physics department, other areas in Brown. And so the technical problem is, how does someone who has studied, say, adolescent mental health for decades, they want to go through and code or analyze the unprecedented amount of data that they now have access to? Because if they could go through all of these, perhaps one of the things we look at is social media messages and conversations among adolescents who are at risk for things like self-harm. And so if we want to understand that, how do, right now it requires a great deal of expertise to annotate all of that data. Maybe an AI could help with that. Maybe machine learning could help with that. We could draw better insights if we could scale it up. But the problem is that those concepts that are being used for the annotation are in the researchers' heads, and we need to get it into the computer. And up until really just a few years ago, the way that we would do that is to get lots and lots of training data for very specific concepts. We were talking about how machine learning works by giving lots of input and output examples. And it used to be the case that you would need many, many examples for how to do that mapping from inputs to outputs. And so one of the things that our group has been working on, and many others that have benefited from this flexibility that large language models gives us, is that we're now developing ways to reduce that cost so that people can adapt models to their tasks and solve problems in areas outside of academic computer science. But that requires sitting down and learning the vocabulary. Like, a lot of what we do in our group is spending time just going to group meetings in other departments, just trying to learn the vocabulary that they're using to talk about their problems. And there's a lot of cycles of that, of, I think you're saying this, let me try to say that back to you. They say, no, that's not quite right. Let me try again. And I think that's one of the things that I've just, that drew me to Brown, is that there's an appetite for that process. And so far it's been, I think, really, really collaborative, productive.
Terrific. So maybe going in a different direction for the subfields and so forth, two of the words that we've been using quite a bit tonight have been intelligence and learning. And of course, for most people in the audience, if we use those two words, you might naturally begin to think about the human brain. And indeed, that's the source of a lot of inspiration, as Ellie mentioned. I wonder, Ellie, if I could kind of have you speak a bit to the work you're doing and the connections to things like cognitive neuroscience and that field here at Brown.
Yeah, absolutely. So I think we're kind of talking about, is this AI versus just machine learning? And also, like, do we think it's doing something smart, or do we trust it to do certain things? In general, I kind of agree. When we talk about like these concrete activities, are we going to trust it to do something important? My reaction is no, we shouldn't yet. I've seen how many things they can mess up. But I actually think I'm very fundamentally quite an optimist about these models, in that I am inclined to think that they're doing something that could be labeled intelligent. Like human level intelligence, probably not yet. But I think there's a lot we can learn. And so something that's been very exciting right now, that you just can't deny is we've never had this before. We've never had a non-human thing that seems this human-like, right? And so, and the reality is, like I said, we've kind of stumbled into this technology. Like, it was not designed by people who are thinking deeply about what does it mean to be intelligent and how do we give that to a computer. We just kind of tweaked some little things, and a lot of people tweaked a lot of things, and we made models bigger, and suddenly we have this. And so it just feels impossible that there's nothing to be learned from that, right? And I think that's when you talk to people in cognitive science and neuroscience, it's like, how could we pass the opportunity to take this artifact that we now have that is producing these behaviors that previously only humans produced and not try to figure out how and why? And this is something that's much easier to study than the human brain because IRB doesn't care what we do. And in many ways, we have access to the whole thing. Like, it's a big model, but it's all there. We can scrutinize any little piece of it. And so there's just a lot of opportunity to say, like, what's happening under the hood? What are the mechanisms it's using? What are the representations? Does that look anything like humans? And it can happen in a couple ways. Maybe it could tell us something that generates some hypotheses about what humans might be doing, because there's a lot of mysteries of the human mind, right? Like, how do we do language? We don't really know. And so this could generate some ideas on things like, well, here's a way of doing it. Maybe humans are doing it that way. And that could actually move progress forward quite a bit. It could also reveal certain things where we're like, oh, we don't trust the models for certain reasons because they're messing these things up. And we figure out how they're doing it. And we see that it's distinctly non-human-like. And maybe we can go make it more human-like, and then we'll trust it more. So there's a lot of this like really good room for this bidirectional feedback between how we think about the human brain and mind and how we think about models. And then there's these like broader connections that I think really do get at the interdisciplinary heart of Brown, because if you have something that is, if not fully human, pretends to be human, it raises all these deeper philosophical questions in the arts and things like that. Like, how do we interpret the literature it generates? How do we interpret the music it writes? Like, there's all of these kinds of conversations that come up once you have this kind of artifact out there. And so I think there's just a lot of opportunity to move research forward because we're now being challenged by the existence of an actual thing. It's not a hypothetical thing anymore, right? And I've really seen like a lot of exciting research come out of that.
Yeah, that's a great point, Ellie. I'd love to run a little further with that, because we've talked about social science, we've talked about STEM up here, but the humanities. You mentioned humanity, but the humanities, the field arts and humanities. And I'm sure people here know, certainly you can generate narrative with ChatGPT, but there are also tools that will generate visual renderings, so art from a prompt. There's even companies that can generate videos from prompts, and this has attracted a lot of interest in Hollywood and other places. So as we reflect on that expressive, creative dimension to the tool, I wonder if any of you would care to offer where you see the arts and humanities at Brown and in other places getting involved, getting engaged in this space.
So I've got really excited. We just put in a proposal for the Digital Humanities Center with John Cayley, who's in the English literature writing here at Brown, to explore this. I was like so excited about this because this is not my expertise, but it's so interesting. So what do we make of this kind of like of the literature that comes out of AI, and how do we interpret it, and what does that say? And this is something where like I can talk a lot about where that came from, what the model knew when it generated it, what was the model thinking when it generated it. That's the kind of stuff I work on. I don't know what that means from a literary criticism perspective or for a broader, theory perspective. But those are the kinds of connections that I think we can make and work through in courses here that seems very exciting, right? Like, I think it would tell us a lot about how to think about models. Like, that's a level of introspection into what they're doing that we typically don't get in computer science, but that would really benefit how we think about them. And I think it's like a clear place where there's this demand for the kind of expertise that comes from the arts and humanities that doesn't typically directly inform what we're doing in CS. Another one is philosophy. I've been accused of stealing philosophers because all of the philosophy PhD students are getting very excited about AI right now. But this is like, there's all of these problems that have been around in philosophy for forever, and people keep working on it, and that's great. Like, this is a time where we're like, we actually need philosophers. Like, we have new problems that have not been thought through in this form before. We need that kind of thinking to help us figure out what is happening right now, right? Like, these are really big questions that are fundamentally philosophical questions. And I think that's really exciting. I don't think that happens every century even, right? There's not always like existential, what does it mean to be human questions at the forefront. That's being driven by like reacting to something very real. So I think those are two areas where I've just really loved engaging with the humanities, and I think they have a lot to offer.
Fascinating.
I'm part of a sort of an informal reading group. It's called the AI reading group, but it's not really about AI. It's about just reflections on technology and humanity. And we have a bunch of faculty from across campus who talk about this, and I've learned a lot from these conversations, just about how old some of these conversations are and how long they've been going on, and how there's a bit of old wine in new bottles. There's a bit of new wine in new bottles, and that's what makes it interesting, knowing what we can learn from the past and what is truly new and different. There's so many things, right? I mean, Ellie mentioned much. So the angle on philosophy is very much so. I mean, when I was developing a class on sort of data science ethics, I did this together. This was my previous institution, but I want to do this here as well, together with folks in the philosophy department. And even simple things like, what does it mean to own your data? What does it mean to have a right to data? These are fundamentally philosophical notions that technical students are not aware of, have had a long history of discourse in these disciplines. And then when you bring that in, suddenly, what I think of the philosophy especially is doing is creating a collection of frames of reference around the way we talk about technology that technology students are not aware of. CS is not a self-critical discipline. We don't reflect on ourselves. It's our failing. It's also our advantage. But the thing is, having that critical filter on the way we talk about technology is very important, because otherwise we're talking at cross purposes.
Right.
Another sort of maybe a more prosaic example, I was talking to Lindsay Kaplan, who will be on one of our panels later on in this series. She's an art historian, and we were talking about ChatGPT and issues of copyright and what it means to if you think of ChatGPT, or not ChatGPT, if you think of DALL-E as creating art by absorbing images and then producing a new image, is that a copyright violation? Is that what an artist does? These are not questions that the people designing DALL-E are going to answer. These are broader questions about what it means to be human, to do art, to create. And I know we'll be talking about the next panel, so I don't want to steal their thunder. But these are, I think, places where there's a lot of conversations to be had between the humanities and technology.
Fabulous. Steve, anything to add there?
No, I only have questions about like what Suresh said about what counts as being creative, what counts as creating art or creating something new, being creative, and.
We'll all attend the next panel and we'll find
Yeah.
Right, exactly. That's
looking forward to it.
Yeah, exactly, Right. Like I think that's like this panel. One of the things I love about being involved in the Data Science Institute. Like we have humanists in working at with DSI, and it's not it. So there are other people who can speak to those things, but I can't.
Fair enough. So I've got one more question here, and then maybe we'll turn to some audience questions as well. So you kind of painted philosophy, I'll put words in your mouth, as this emerging job market, right?
Yes.
Which it really is.
I've been saying that, and I feel guilty if then the philosopher PhD students are like, where are all these jobs you said were going to exist? But I feel like exactly.
So applied philosophy has this renaissance moment. So as we think about the job market, there are the school of thought out there that technology is going to do away with jobs, or by making people more efficient, we'll need fewer in the workforce. And of course, there's eons of experience with technological revolutions, and the car put horse and buggy drivers out of business, yes, but created all kinds of other industries and jobs and opportunities. So, not asking you to opine necessarily on the big labor market questions, but more how we think about training our students to be nimble, to be agile, to be versant as they go forth. Thoughts on how we should be approaching this in the academy?
Yeah, I think there's one aspect under that question is just how to interact with these tools, how to do your job with, or whatever it is that you want to do with, in a world where there are people using AI to maybe compete with you, or to put things out there that you have to assess whether they're correct or not. And I think that's a skill in itself, that where a new type of technology literacy has to be developed. And it's kind of subtle. So one thing that I can't remember who to give credit to, but it was somebody on the faculty mailing list pointed out that one interesting thing with ChatGPT was that it could seem to prove any theorem that was on the homework in one of their homework assignments. And they said, they gave it, prove this theorem, prove that theorem, and it gave all these, answers. But then they thought about it more and they said, prove the opposite. Prove the negation of this theorem, and it also provided a very convincing sounding theorem with a very subtle flaw in it. And so that kind of discrimination about, again, going back to trust and when to rely on these tools, I think is going to be a very important question. To your point about the difference between an AI and a calculator, it's clear when to use a calculator. It's not clear when to trust AI at this point.
Fair enough.
Yeah, I would say, thinking about that, this feels like an exact advertisement for this liberal arts type of education, right? Because it's in the same way that you try to use the 4 years to teach students how to evaluate what other people are telling them and decide what role that should play in their own thing, to take all of this stuff in and then think critically about it and make a intelligent and positive contribution. I think we really have to be thinking of AI in those kinds of terms. So they need enough tech literacy to kind of know where this is coming from, because it's not coming from another person. But then also take it as that, not like a calculator, right? So you can't just offload tasks to it and take it as this output, but you have to be able to think critically about it. Why might it be giving this answer? It's not sometimes you think when you read what a person's writing, what are their incentives, what are their motives? There's equivalent versions of those questions for AI, why might I be seeing this? Where could this answer be coming from? And then think about how to integrate it in that sense. So I think just thinking about how to work with technology, this kind of technology and all these different facets with that kind of critical liberal arts lens seems like it's going to be essential going forward.
I mean, it's a simple example I think about, right? We all have used now Google or Bing, whatever favorite search engine search, for a long time now. And I've learned the hard way that if Google search says that this restaurant is open and it's a holiday, I should probably call and check, because I have learned how to interact with the technology and not always trust what it does for me. I think this is a microcosm of, we don't yet have that sophistication with these new tools because they're so new, and that's okay. We will, but it takes time. And so that's one thing. On the flip side, I think, we've all talked about how people who may not have computer science expertise may need to get more facility with understanding how to interact with these tools. I think it's also important for computer scientists to get more facility with learning about the world that these tools they're building are inhabiting. So, for example, Brown CS has the Social Responsible Computing Program, which brings in in every classroom, students are being asked to think about what is the likely societal impact as appropriate for the class that if they're learning about AI, then it's natural. For other classes, maybe it's a little bit more early stage, even things like you're learning how to make shorter spots, and then they're told about how, Waze, which is this app which many of you have used to route yourself along the best path, will use a shortest path algorithm, but will route everyone along the same path. And it turns out there are these small neighborhoods near LA that were getting tons of traffic down their streets because Waze decided to push everyone through. So a small thing like find a shortest path, which is a standard canonical graph algorithm, becomes something with broader societal impact. Yes. And so the SRC program tries to teach CS students how to think more critically about the tools they're building, which is the other side of this equation of you need that as well.
Right. So, Heaney, I wonder if we have questions coming in, or you can prompt people for how we're going to collect them.
Yes, definitely. So the QR codes up here on the monitors on either side of the panelists, you can use to submit questions, and then we want to take them through that, and I'm sorting them into themes because there are a lot of related themes. So I will be doing that on the fly, and you can, if I don't ask your question, it's my fault, not anybody else's here. But I'll start with, there were a number of questions that also came in during registration, and including the questions we're getting now. There was a theme of how generative AI might intersect with collegiate pedagogy. And there are many questions about writing and writing assessments, which I think we'll definitely talk about at the next panel. But there's interest in hearing about how generative AI might have changed the classroom in computer science as well. And I don't know if you have any examples you'd like to share from the department or from your own teaching.
Sure. Arguably one of the better things that large language models do right now, and arguably they can be more relied on for, is generating code. That a lot of I know from my graduate students, they all are like, oh yeah, I'm way more productive with maybe you've heard of Copilot, these things that will suggest code, especially kind of like what we might consider boilerplate stuff that have written 10 times before. I think the challenge that a lot of us are facing in computer science, particularly in the introductory courses, which I don't personally teach, is that learning how to write that boilerplate code is the pedagogical goal. So I think that I know that a lot of our faculty have been thinking very critically about this, and they could speak much more better about it. But the high level points are things like changing your evaluation methods to be more than just saying, does your code run? Does it produce the output? Students are now being asked to do things like review their code, provide reviews of their own code, descriptions of what it's doing, and sometimes speak to like ways that it could go wrong, things like that. So those are all ways that we're having to probe sort of more for understanding and not just look at the generated output as the proof of learning.
Other classroom experiences?
I actually used ChatGPT once to write a particular piece of R code to generate a plot that I could not Google the answer to. It was great.
Yeah.
and it was great because I could run it and then see if the answer was what I wanted. I could check it. And I think that's
Right
the
away.
key thing. I could check
Yes.
it right away. It wasn't where I had to rely on the answer without knowing if it was going to work. So that's one thing. I liked your theorem proving example. Back in the day when I was teaching algorithms, this would have been very helpful to have people try to write proofs with ChatGPT and have them demand the proof of the correct statement or the incorrect statement as well, and find what went wrong. Mm-hmm. As a pedagogical device, right? This is in like discrete math classes. This is a standard trick. You give students a proof that's wrong, and they have to figure out what's wrong in it. And so that would be. I mean, and that's not something I've done because that's not what I teach right now. But I have done that in the past, and that would be a very good thing to do. Mm-hmm.
Yeah, I don't think I have anything specific. I think it's these similar themes, getting people to explain their code, which arguably is a better assessment anyway, right? Like what I always have this concern about students just throwing their code against the auto grader and just guessing and checking until they're getting a perfect score, but I'm not sure that they actually understood it. So maybe this forces us to write better evaluations or have better assessments of students anyway.
Terrific. We have another question.
Yeah, another question mentions that one of the things we didn't define today is algorithmic bias, and what kinds of biases might we be worried about in the context of generative AI and
How many
ChatGPT?
days do you have? I teach a course in the spring. No, I'm kidding. So, algorithmic bias is a complicated thing to define, right? One of the many fights we had when writing the blueprint was getting a bunch of lawyers to agree on how to define algorithmic bias. But roughly speaking, the concept behind algorithmic bias is the idea that your system would, let's say you're making predictions or decisions about people, that it would unfairly, come to some conclusions about one group of people based seemingly on, demographics or other features. In the case of bias in generative AI, we are actually working together on a project on this where I think, maybe I'll let you speak, because I think you know more about this than I do, but why don't you speak to what it means for bias in generative AI?
Right, so it's definitely, people do not know, right? I mean, defining bias in humans is hard as well, and it's not made any easier when the thing is an AI system. So like the way that the systems are trained is really by learning to mimic statistical associations in the world. And so like one of the things actually an undergrad research project, but I think she's not here anymore. I was going to call her out and embarrass her, but I think she probably had homework to do. But she's been looking at this. Gender bias is one of the things that's been really popular to study because we can look at models' tendency to produce specific pronouns, and you can measure it pretty clearly, and you can see really clear trends where, for example, if you say something like, the nurse said that, it will say she over he almost 100% of the time. Like it thinks that nurses are female, right? And like, what do you do with that information? Like it's not a statistically wrong guess to make. Like most humans would probably make a similar guess if forced to make a guess. And the model is forced to make a guess. That's what it is. It's a statistical model. So we're trying to figure out, is that a problem or not? And then this is where it does kind of go up to philosophical issues. Like it boils down to, I mean, we were just talking this morning about some cool results that I don't know how replicable they are, but what the suggestion was, like maybe for certain things like the word nurse, it might be considering the feminineness to be intrinsic to what it means to be a nurse, which seems like a lot more of a problem than treating it as like a property that is often true of nurses, which would be encoded differently. And so like having to understand it at that level and saying like, this is a deep problem because the model's not saying, oh, it tends to be the case that nurses are female. It's saying part of what it means to be a nurse is that you're female. Like those are very different things, and they might have different consequences for how we want to regulate the models, how we want to correct them. But that's the level at which we're just starting to talk about things, starting to try to understand things. We, again, don't know how the models work, so it makes it really hard to define what is or isn't wrong with them without even understanding what they're doing. Yeah. So it is a wide open topic, I would say.
Another question mentions that AI may only exacerbate disparities between haves and have-nots within societies, our society, and around the world. In particular, how can people living in the developing world benefit from rapid developments in AI?
So there's a number of examples of this. So this is a very important question because it's a real problem. So for example, I don't know what the statistic is, like some very, very large fraction of text in the world is all English text. Right. There's very little, there's 7,000 languages, but most of them have very little text. And as we know, you need a ton of text to build a model that's accurate enough to converse with, for example. There's this group, for example, in New Zealand that is trying to sort of essentially build digital frameworks for the Maori language, and has done a lot of very careful curation, made sure the ownership is kept with the Maori people, and has built tools and is not sharing those tools with OpenAI, with other large entities, because they want to keep them under their control. And that kind of homegrown, from the ground up building is very, very important. And that's something that, is critical to do. You can't have all the development happening only from the big tech companies or only from the West or only from the US. So to that extent, there's this whole discussion about democratization of AI. I mean, that's a term, again, that gets thrown around a lot. But I think there's a real sense in which, I call it small AI, not big AI. You want the ability for communities in their own localities to build tools that work for them. And it's perfectly fine that it doesn't work for anyone else. That's okay, because it works for them. And we need much more of that kind of work. And we need to value that kind of work and value that kind of research. It doesn't have to, does your thing scale to 100 million? It does not matter. It should not matter. Because if we want to really get the benefits of AI broadly, we need to encourage and value work that allows us to do things at different scales for communities and empower communities to do it. So there's a policy angle to this I will not talk about now, but I think that's an important research question as well.
Yeah, this is exactly the socio-technical infrastructure you're talking about, because I think the big tech companies have a history of having a mission of making the world a better place and deciding what the world needs and giving it over. And then like social media is a good example of that, right? So this is like an opportunity to do it better, right?
And I would add to that we in academia are some of the people that can do that I think our nonprofit, our service mission, and empowers us to look at some of these questions in ways that companies that's not what they're there for. And so Ellie and I have both contributed to kind of large distributed international collaborations around large language models that have had an impact in the AI community. And I'm glad you mentioned the multilingual aspect too, because that's something that some of the students in our group are thinking a lot about. And what we've recently found is that there are lots of interesting implications for the imbalance in languages, in data, amount of data and quality of data that has been curated for different languages. We recently released a report that showed that a lot of the safety mechanisms in GPT-4, the things that sort of prevent it from answering problematic queries or providing harmful advice. One of the ways that you can circumvent them, that is by using Google Translate to translate your query into what is considered a low resource language, like Zulu or Scots Gaelic. And then the model will happily reply to you in that language, which you can then translate back. And what this reveals is that the investment in safety likely has not been made uniformly across these different languages, even though there are billions of people who speak these what are considered low resource languages. So I think that's an important issue to continue to study. Again, something that we can help with in academia.
Boy, fascinating, wide-ranging conversation. We're at the top of the hour, and I'm going to take moderator's prerogative and pose one more question, but I'm going to say lightning round format, so quick answer. And this is for the audience here, for the folks who are tuning in and listening. If there were one thing about the perceptions, the beliefs that people have in AI, what is it you'd like them to rethink or re-examine as a result of the conversation we've had? So maybe since Steve just spoke, we'll start from this end. Ellie, do you want to offer your thought on that?
Yeah, sure. I mean, I think the thing I always like to emphasize is actually how little we understand the technology right now, right? So there's a lot of interest in deploying things. And so there's always a lot of talk that makes it seem like people are like, oh, we can do these things for you. Like the safety guarantees is a really good example. I didn't know about that report. That's really cool. I want to read it, yeah. Super interesting. Yeah, but that's an exact thing. Like people are very quick to make promises about it. And the truth is we just can't make promises about it right now. Like the science has not caught up to the technology. So I think we're open for a lot of interesting stuff going forward.
Good caution. Thank you. Suresh, something for people to rethink.
I would say 3 thoughts. AI is not magic. Its progress and direction is not inevitable. And we have the power and the skill to design the world we want to live in. We don't have to sit helplessly by.
Succinctly posed. Thank you. Steve.
I was going for something like AI is not magic. I like that too. But I think
all the computer scientists saying that.
Right, exactly. But yeah, that's really maybe one of the most important takeaways. Maybe I can end with I still like that iceberg metaphor that it seems like it's popped up out of nowhere, but actually it's been under the surface for a long time. That people have been making incremental progress in this direction for literally decades, and now that it's popped up. Sometimes it's easy to overestimate its size. When it's producing very plausible sounding, very convincing text, it's easy. I see this with students. I see it sometimes in things that I first read that have come out of a large language model. It's easy to panic and say, wow, this is brilliant. I can't believe a computer did this. And then as you start to pick at it, you realize, wait a minute, there's actually some bugs that are in what's been generated that are a little more subtle. So keep an eye out for those and remember it's not magic.
All right, let me ask the audience to join me in thanking these wonderful panelists for a great conversation.
Thank you.
Thank you.
And we have refreshments in the back of the room.